In October 2025, Sikorsky shocked the defense world with just one announcement. The company unveiled the S-seventy UAS U-Hawk, the first fully autonomous, completely unmanned version of the legendary Black Hawk helicopter, transforming America's most iconic utility helicopter into a pure unmanned aircraft system capable of operating autonomously from a tablet interface. How did Sikorsky achieve this transformation so quickly? What terrifying new capabilities does this autonomous Black Hawk bring to the battlefield? Join us as we explore how the U.S. unveiling of the first-ever unmanned Black Hawk helicopter is transforming the future of military aviation and battlefield logistics. Sikorsky had been working with the Defense Advanced Research Projects Agency on the Aircrew Labor In-Cockpit Automation System program, better known as ALIAS, since the early 2010s. This initiative sought to develop drop-in autonomy kits for installation on existing aircraft, reducing pilot workload and eventually enabling fully autonomous flight. Through ALIAS, Sikorsky flew a UH-60A Black Hawk completely unmanned for the first time, demonstrating that the technology could safely control these complex rotorcraft without human intervention. That success validated the core technology, but ALIAS retained the cockpit and crew stations, treating autonomy as an assistance system rather than a complete replacement for human pilots. In 2024, Sikorsky made progress and advanced the concept with optionally piloted vehicle demonstrations that captured widespread attention. At the previous year's AUSA conference, the company remotely flew an OPV Black Hawk in Stratford, Connecticut, from the show floor in Washington, D.C., over 200 miles away. Operators on the convention floor used tablet interfaces to control takeoff, flight maneuvers, and landing, with safety pilots aboard the aircraft but not touching the controls. During Exercise Northern Strike in Michigan, a National Guardsman with zero previous aviation background learned to operate the OPV Black Hawk in less than an hour, successfully transporting a 2,900-pound water buffalo sling load entirely by remote control. The soldier even controlled airborne troop drops and multiple HIMARS tube hookups from a Coast Guard vessel 70 nautical miles away on Lake Huron, demonstrating how intuitive the Matrix autonomy system had become. These demonstrations proved the technology worked, but Sikorsky executives recognized they could push much further. Why retain the cockpit and crew stations if the aircraft could fly entirely autonomously? Why not maximize the available space for cargo and mission equipment? The idea emerged: purchase a surplus UH-60L Black Hawk from the Army, completely redesign the front section, remove every component related to human flight, and create something unprecedented: a true unmanned utility helicopter with the payload capacity and operational range to revolutionize logistics. The team at Sikorsky Innovations, the company's rapid prototyping division, accepted the challenge to transform this concept into reality in under 1 year. The engineers started with a standard UH-60L Black Hawk, a variant that entered service in the late 1980s featuring upgraded T700 GE 401C engines and improved lift capacity compared to earlier A models. This helicopter had served honorably for years before being retired from frontline service, but its basic airframe remained sound, with thousands of potential flight hours remaining. The transformation began with brutal efficiency. The entire cockpit section, including the distinctive greenhouse canopy, instrument panels, pilot and co-pilot seats, flight controls, and every system designed for human operation, was removed. Engineers didn't simply disable these systems. They physically cut away the forward fuselage and replaced it with something radically different. Where the cockpit once sat, Sikorsky installed actuated clamshell doors and a powered cargo ramp similar to those found on cargo aircraft, like the C-130 Hercules. These doors open forward, revealing a flat-floor cargo bay that extends much further forward than in conventional Black Hawks. This single modification increased usable cabin volume by 25%, a dramatic expansion that fundamentally changes what the aircraft can carry. The removal of seats, crew stations, life support systems, and all the structures supporting human occupation freed up thousands of pounds of weight and hundreds of cubic feet of space, all now available for mission equipment, cargo, or fuel tanks. The flight control transformation proved equally comprehensive. Conventional Blackhawks use complex mechanical linkages connecting the pilot's cyclic, collective, and pedal controls to hydraulic actuators that move the rotor blades and tail rotor. These mechanical systems require constant maintenance, regular adjustment, and significant weight. The U-Hawk replaces this entire architecture with a third-generation, low-cost fly-by-wire system that translates electronic commands into rotor movements through computerized actuators. This isn't the expensive, highly redundant fly-by-wire found on fighters like the F-35. Sikorsky deliberately designed an affordable system that achieves safety through simplicity and proven technology rather than through layered redundancy. The heart of the U-Hawk's autonomous capability is the Matrix technology suite, refined through thousands of flight hours on multiple aircraft types. Matrix isn't aircraft-specific. Sikorsky has flown it on rotary wing helicopters, fixed-wing aircraft, and various unmanned systems, accumulating over 1,000 flight hours, validating the software and hardware. This maturity proves critical because the autonomous flight of helicopters presents challenges far exceeding those of autonomous cars or even fixed-wing drones. Helicopters operate in three-dimensional space with 6 degrees of freedom, respond to control inputs with complex coupled dynamics, and must handle emergencies such as engine failures through rapid, precise maneuvers. The fact that Matrix has successfully navigated these challenges across different platforms demonstrates robust engineering. What makes Matrix truly revolutionary is its scalability. The system can operate in multiple modes ranging from full two-pilot manual flight with autonomy providing assistance, through single-pilot operation with the autonomy functioning as a competent co-pilot, all the way to completely autonomous flight with no humans aboard. This flexibility allows operators to dial up or down the level of autonomy based on mission requirements, crew availability, and risk tolerance. For missions in permissive environments with low threat levels, full autonomy makes sense. For complex special operations in denied territory, having experienced pilots aboard with autonomy, reducing their workload might prove preferable. The ability to choose represents a fundamental advantage over purpose-built drones that cannot accommodate human crews. Operating the U-Hawk appears almost comically simple compared to flying conventional helicopters. Traditional Black Hawk pilots undergo months of intensive training, learning to coordinate cyclic, collective, and pedal inputs while monitoring dozens of instruments and maintaining spatial awareness. They master complex procedures for normal operations, emergencies, and combat maneuvering. In contrast, U-Hawk operators require minutes of instruction. They use a ruggedized tablet that displays a simplified interface showing the aircraft's location, status, and mission parameters. To start the aircraft, the operator touches a single button labeled crank. The Matrix system then executes all pre-flight procedures autonomously, checking hydraulic pressures, starting the engines, running system diagnostics, and preparing for flight without human intervention beyond that initial button press. Once running, the operator assigns mission tasks through the tablet interface. They might select cargo delivery and designate pickup and delivery locations by touching points on a map. The Matrix system automatically plans the flight path, calculating optimal altitude, speed, and routing based on weather, terrain, known threats, and aircraft performance. The operator approves the plan, and the U-Hawk executes autonomously, taking off, flying the route, landing at the destination, waiting for cargo to be loaded or unloaded, then continuing to the next waypoint or returning to base. Throughout the flight, the system continuously monitors aircraft health, navigation accuracy, and environmental conditions, automatically adjusting for winds, weather, and unexpected obstacles. The expanded cargo capacity transforms mission possibilities. Standard Blackhawks can carry 2 joint modular intermodal containers, military standard boxes measuring roughly 6 feet by 8 feet that hold equipment, ammunition, supplies, or other cargo. The U-Hawk accommodates 4 JMICs, doubling the containerized cargo capacity. This expansion isn't merely incremental, it crosses critical thresholds that enable entirely new missions. A forward operating base requiring ammunition resupply might need 4 container loads to sustain operations for a week, with conventional Blackhawks requiring 2 sorties, with crews needing rest between flights. The U-Hawk completes the mission in one autonomous sortie, potentially flying at night when crews would normally be sleeping, dramatically compressing the logistics timeline. Perhaps most striking is the U-Hawk's ability to carry a complete HIMARS rocket pod containing 6 precision-guided rockets. The high-mobility artillery rocket system has proven devastatingly effective in Ukraine, with Ukrainian forces using American-supplied HIMARS to strike Russian command posts, ammunition depots, and logistics nodes with remarkable precision. However, HIMARS batteries require constant ammunition resupply to maintain their firing rate. Conventional resupply uses trucks vulnerable to artillery, drones, and air attack. The U-Hawk offers a revolutionary alternative. Load a complete rocket pod aboard, fly autonomously to the battery's location, potentially dozens of miles behind friendly lines. Land, allow crews to extract the pod and load it onto their launcher, then depart. The entire process occurs without exposing human pilots to enemy fire and can happen day or night, regardless of weather. The ability to deploy unmanned ground vehicles opens even more possibilities. Sikorsky has demonstrated loading vehicles, such as the HDT Hunter Wolf 6x6 UGV, directly into the U-Hawk through the forward clamshell doors. These unmanned ground vehicles can then drive off the ramp at the destination and continue their mission autonomously. Imagine a reconnaissance mission deep in enemy territory where defenders would immediately engage any helicopter attempting to insert troops. The U-Hawk flies in autonomously at night, lands in a concealed location, deploys a UGV equipped with sensors, then departs. The ground vehicle conducts surveillance for hours or days, gathering intelligence while the U-Hawk returns safely to base. When the mission completes, the U-Hawk returns, the UGV drives back aboard, and both extract without ever risking human lives. Missile transport capabilities deserve special attention. Beyond HIMARS pods, the U-Hawk can carry 2 naval strike missiles, long-range anti-ship weapons capable of hitting targets over 100 miles away. These missiles typically launch from surface ships or land-based platforms, but the U-Hawk creates a mobile, rapidly deployable option. Picture a scenario where intelligence identifies an enemy naval task force approaching a contested strait. Ground-launched missiles in the area have been destroyed or are out of position. The U-Hawk could autonomously fly to a pre-positioned launch site, land, allow crews to remove and set up the missiles, then depart before enemy forces locate the position. This flexibility transforms static coastal defense into a dynamic, responsive anti-ship capability that enemy naval planners must account for. The launched effects capability represents perhaps the most futuristic application. Launched effects are essentially drones carried aboard manned or unmanned platforms and deployed during flight to extend sensor range, create decoys, or deliver strikes. The U-Hawk can carry quivers of these small drones, which are secured in the cabin, and fly to a designated area, releasing them to form autonomous swarms. These swarms might conduct area reconnaissance, with dozens of small drones spreading across hundreds of square miles searching for targets. They could perform electronic warfare, jamming enemy communications and radars, while the U-Hawk loiters safely outside engagement range. Most ominously, they could deliver kinetic strikes, with each small drone carrying a small warhead and autonomously attacking vehicles, radar sites, or personnel. The internal fuel tank option extends operational reach dramatically. Standard Black Hawks carry 360 gallons of internal fuel, providing several hours of flight endurance depending on the mission profile. External fuel tanks can be mounted on stub wings, but these occupy hardpoints that could otherwise carry weapons or equipment. The U-Hawk's expanded internal volume allows installing additional fuel tanks inside the cabin without sacrificing weapon stations or external cargo capacity. With these internal tanks, the aircraft can self-deploy over 1,850 miles or loiter for up to 14 hours without refueling. This endurance enables missions impossible for conventionally crewed helicopters, where pilot fatigue limits operations to a few hours before crews must rest. The psychological impact of this capability cannot be overstated. Enemy forces face the prospect of autonomous helicopters that never tire, require no brakes, and can operate around the clock. A single U-Hawk could conduct resupply missions continuously for days, landing only to load cargo and refuel. Human crews working the same schedule would require multiple shifts, extensive support personnel, and significant logistics to sustain operations. The autonomous platform eliminates these constraints, potentially doubling or tripling the sortie generation rate of conventional helicopter units, while reducing the manpower requirement by 75% or more. Sikorsky's focus on commonality with existing Black Hawk fleets creates enormous strategic advantages. Every military operating Black Hawks worldwide, from the United States to Jordan to Colombia to Australia, maintains infrastructure supporting these helicopters. They stock spare parts, train mechanics, operate maintenance facilities, and maintain supply chains optimized for Black Hawk support. The U-Hawk leverages this entire ecosystem. Approximately 80% of its components remain identical to UH-60L models, meaning existing spare parts inventories work without modification. Mechanics trained on conventional Black Hawks can service U-Hawks with minimal additional training. This commonality dramatically reduces the cost and complexity of fielding the new capability compared to developing an entirely new unmanned helicopter from scratch. The conversion potential represents a goldmine for nations with aging Black Hawk fleets. Countries worldwide operate hundreds of older A and L model Black Hawks, approaching the end of their service lives. Traditionally, these aircraft would be retired and scrapped or sold to less developed nations at deep discounts. The U-Hawk conversion offers an alternative. Rather than discarding these airframes, convert them into autonomous utility platforms that can serve for decades more. The conversion cost remains classified, but Sikorsky officials say it's significantly lower than the cost of purchasing new aircraft. Igor Cherepinsky, director of Sikorsky Innovations, emphasized that they focused on efficiencies in the retrofit, designing and manufacturing vehicle management computers, actuation components, and airframe modifications that can be rapidly applied to additional aircraft. Middle Eastern customers represent particularly attractive conversion candidates. Nations like the United Arab Emirates, Saudi Arabia, and Jordan operate substantial Black Hawk fleets acquired over the past decades. Some of these aircraft face retirement as newer models enter service. Sikorsky pitched the conversion concept at the Dubai Air Show in November 2025, presenting to regional customers the value proposition of converting old Black Hawks into autonomous platforms rather than retiring them. The pitch resonated because it offers a cost-effective way to enhance capabilities while maximizing existing investments in infrastructure and training. One challenge involves export licensing for the Matrix autonomy technology, which Sikorsky is currently working to secure from the U.S. government. The strategic calculus for contested logistics drives enormous interest in the U-Hawk capability. Modern great power competition scenarios, whether in Eastern Europe against Russia or the Indo-Pacific against China, envision conflicts where traditional supply lines face constant threat from artillery, missiles, drones, and air attacks. Forward bases require ammunition, fuel, food, medical supplies, and spare parts to sustain operations. But delivering these supplies through contested areas risks losing expensive aircraft and irreplaceable crews. The U-Hawk offers a solution, except some. Attrition of unmanned aircraft as the cost of maintaining logistics flow, rather than accepting crew losses or allowing forward units to run out of critical supplies. Consider a Ukrainian-style artillery war where distributed rocket and tube artillery batteries require constant ammunition resupply. Truck convoys face destruction from counter-battery fire, loitering munitions, and tactical drones. Manned helicopters flying resupply missions suffer unacceptable losses to man-portable air defense systems. The U-Hawk changes this equation entirely. Autonomous helicopters fly multiple sorties daily, delivering ammunition containers directly to battery positions. If enemy air defenses destroy a U-Hawk, the loss involves an aircraft but no crew. The same mission attempted with a manned helicopter means dead or captured pilots, potentially triggering combat search and rescue operations that risk additional aircraft and personnel. The mathematics of acceptable risk fundamentally shifts when removing humans from the aircraft. Medical evacuation applications deserve special examination, despite the U-Hawk lacking onboard medical personnel. In conventional medevac operations, specially configured HH-60M, Black Hawks carry flight medics who provide emergency care during flight. This capability saves lives but requires exposing medical professionals to combat. The U-Hawk could perform evacuation under specific circumstances, where stabilized casualties need transport but don't require in-flight medical intervention. Imagine casualties who have received initial treatment at a forward aid station and are stable enough for transport to a field hospital. Loading them aboard a U-Hawk and autonomously flying them to the hospital avoids risking a medical crew while still reducing the time casualties spend in austere conditions. This isn't a replacement for full medevac capability, but it provides an additional option that commanders can employ based on tactical circumstances. Special operations units see enormous potential for autonomous Black Hawks supporting their missions. The 160th Special Operations Aviation Regiment, the famous Night Stalkers, operate highly modified MH-60 Black Hawks for infiltrating and extracting special operations forces from denied territory. These missions involve tremendous risk, with pilots flying low-altitude, high-speed profiles through defended airspace. The crews accept these risks because their skills prove essential for mission success. However, some special operations missions might benefit from the use of autonomous support aircraft. A team conducting a raid might need immediate resupply of ammunition after heavy contact with enemy forces. Rather than risking a manned aircraft flying into an active firefight, a U-Hawk could autonomously deliver the ammunition, potentially sacrificing the aircraft but ensuring the team receives critical supplies. The firefighting application Sikorsky mentioned shows civilian potential beyond military operations. Forest fires devastate thousands of acres annually, and aerial firefighting provides a critical capability for containing these blazes. Traditionally, this requires pilots to fly into dangerous conditions, with heavy smoke reducing visibility, extreme turbulence from fire-generated winds, and the constant risk of mechanical failure while operating at low altitude in mountainous terrain. With these amazing possibilities, it's obvious the unmanned Black Hawk isn't just a new aircraft. It's a signal that the rules of warfare are quietly changing. The question now is how nations adapt when logistics, endurance, and risk are no longer limited by human endurance. When helicopters don't sleep, don't hesitate, and don't come home in coffins. The future of battlefield scouting is here. Intelligence, surveillance, and reconnaissance have shaped warfare for centuries, leading to iconic machines like the Bell H-58 Kiowa, and more recently, the cutting-edge Bell 360 Invictus. The Kiowa earned its stripes in decades of combat, but its time is over. Now the Invictus is stepping in, a sleek, stealthy prototype designed for speed, precision, and deadly firepower. But just how big of an upgrade is it? And how are rival nations reacting to this game-changing rotorcraft? Join us as we discuss the history-making potential of the Bell 360 Invictus. The international arms race has been a subject for debate since time immemorial, with each of the superpowers snatching at each other's heels in a bid to control the world. However, to gain control, power is of utmost importance, both military and economic. Although super nations like China, the United States, the United Kingdom, and the Kremlin have somewhat found ways to go neck and neck economically, military might seem to be at the crux of it all, with nations particularly afraid of an invasion or going to war with countries that have superior military technology. Enter the United States. Warfare technology has evolved exponentially over the years, from discovering fire to discovering iron and creating swords, before guns and drones even became a thing. However, as much as ground combat has been a big part of conventional warfare, the tide soon turned heavily towards aerial combat. There is a popular belief that whoever controls the air can break the opponent's spirit, therefore winning half the battle. Hence, top nations like China, Russia, and the United States continue their quest to take over the skies, with fighter jets, bombers, and helicopters at the forefront of their aerial creation. The United States Army has been known over the years as arguably the world's strongest military out there, and not just by the sheer volumes of personal wars or affiliate wars that they have fought and won, but also by their display of some of the world's leading technology in ground combat and aerial warfare, especially their surveillance choppers. The Vietnam War was an eye-opener on the capabilities of the United States' depth in aerial technology, especially with the addition of the Bell H-58 Kiowa Scout helicopter. However, as the years rolled on, the United States Army wanted something different. An upgrade so lethal that it could serve multiple purposes in a war, ranging from stealth missions, including intelligence gathering, surveillance, and reconnaissance, to being lethal as a weapon capable of serious attacking threats. Hence, the introduction of the Bell 360 Invictus. The Bell 360 Invictus was a proposed chopper design that was created to satisfy the United States military's recent urge for a better, faster, and lighter helicopter capable of performing intelligence, surveillance, and reconnaissance, otherwise called ISR functions, while carrying enough ordnance to deal damage in aerial-to-aerial or air-to-ground combat. To that effect, the United States Army created the Future Attack Reconnaissance Aircraft, or FARA program in 2018, with an aim to develop a successor to the Vietnam War hero, the Bell OH-58 Kiowa Scout helicopter. But what made the O-58 so special until the Army requested an upgrade? Like nearly every military technology, war and control have always been at its base, spurring on the creation of an instrument of war that ensures dominance. In the 1960s, the United States military decided on a need for a light observer helicopter, otherwise called LOH Ergo. They approached the United States Navy, which in turn met with 25 helicopter manufacturers to place a request on behalf of the United States Army, which has asked for proposals from all 25 companies, striking up a competition to make an impression. One of the manufacturers was Bell Helicopter, which made the first model of the OH-58, named the D-250. At first, the D-250 model was rejected. The Hughes and Fairchild Hiller prototype, the Hughes OH-6 Cayuse, was selected in May 1965. When everyone thought it was the end for Bell Helicopter, they went into problem-solving mode, fixing the cargo space on the helicopter by redesigning the fuselage to be sleeker and more pleasing to the eyes, while also adding roughly 16 cubic feet of cargo space in the process. This upgrade helped to improve the image for getting into the commercial market. The new design was designated as the Model 2 06A, and Bell President Edwin J. Ducaille named it the Jet Ranger, denoting an evolution from the popular Model 47J Ranger. However, in 1967, the Army reopened the Light Observation Helicopter competition and sought out the companies one more time, but with a completely different specification from what was given the last time. As expected, Hughes Tool Company tried their hand again at the possibility of getting the Army contract for the second time. This time, they couldn't meet the contractual demands, and Bell Helicopter was finally chosen. They submitted their upgraded Model 2 06A and subsequently won the bid. The Army recognized the stealth capacity of the Model 2 06A and just could not pass up on it. Consequently, the United States Army designated the Model 2 06A as the OH-58A Kiowa in honor of the Native American tribe. The O-58 was intended for just observation and stealth missions at first. However, the Army Helicopter Improvement Program, otherwise called the AHIP, demanded a more robust version of the OH-58A, and Bell Helicopter delivered once again, sealing the trust of the Army in them. The more robust version of the Bell Helicopter was designed to function in hunter-killer missions. Hunter-killer missions involve a pair of aircraft where one functions as a scout owing to its stealth capabilities to provide intelligence, surveillance, and reconnaissance features, ergo, taking the role of hunter, while the killer is the attack helicopter that engages and attacks the targets identified by its hunter pair. Bell Helicopter created the O-58D to play this role when Congress agreed to the release of $138 million. The O-58 Kiowa models were designed as a family of single-engine, single-rotor military helicopters, principally tasked with the responsibility of observation, utility, and direct fire support. However, as the years rolled by, the Army instigated upgraded versions that could function as hunters, identifying targets for other platforms such as the Bell AH-1 Cobra attack helicopter and ground artillery, field guns, howitzers, mortars, self-propelled artillery, and multiple rocket launchers. However, it was a little too counterintuitive to have a scout helicopter that relied heavily on the human factor to conduct observation. Hence the need for later designs, which were retrofitted with cutting-edge sensor technology that performed the intelligence gathering, surveillance, and reconnaissance roles to perfection. While the early Kiowas had a twin-bladed rotor style, the upgrade to the rotor started with the creation of the more robust version of the OH-58 Kiowas. While the earlier ones had a flexible rotor, the OH-58 upgrade was made entirely of composite materials, meaning that they mixed up materials like fiberglass or carbon fiber to create advanced materials, which helps the helicopter maintain balance while it moves. Sacrificing the heaviness of the early Kiowas was the crux of the light observation helicopter program, hence their rationale for choosing rigidity and strength from a four-bladed motor built out of composite materials over the two-rotor blade that relied on mechanical hinges and flexibility. In August 1969, America officially unveiled the early Kiowa in South Vietnam for the first time, accompanied by a new equipment training team, NET, comprising personnel from both the United States Army and Bell Helicopters. Although Bell had finally won the new light observation helicopter contract with the United States Army, they did not immediately replace the OH-6 Cayuse during operations, as they were both used together until the end of the Vietnam War. While both helicopters were in use during the Vietnam War, the OH-58A Kiowa helicopter had its first stint in real-life battle. On March 27, 1970, a Kiowa was shot down during a scout mission in South Vietnam, claiming the lives of the pilot, Warrant Officer Ralph Quick Jr., and an artillery spotter, Lieutenant Colonel Joseph Bonoski. Getting shot out of the sky during a battle damage assessment mission sent a direct message to the Army that they needed much better stealth features and sensors that could help with intelligence gathering, surveillance, and reconnaissance, otherwise called the ISR missions. Although the helicopter provided some success, especially during Operation Desert Shield, where it was utilized as a hunter to spot and target lasers. During Operation Desert Storm, the United States Army deployed 130 OH-58D helicopters that worked alongside the other Army attack helicopters, 145 AH-1 Cobras, and 277 AH-64 Apaches, and participated in a wide variety of critical combat ground forces missions. During Operation Desert Shield and Operation Desert Storm, the Kiowas collectively flew nearly 9,000 hours with a 92% fully mission-capable rate. The upgraded Kiowa Warrior had the lowest ratio of maintenance hours to flight hours of any combat helicopter in the war, meaning that it did not have to be serviced as much as other aircraft. Fast forward to July 2020, and the United States Army decided to retire the OH-58C from service. With warfare advancing and technological improvements not lagging behind, the United States Army is also in the global arms race and looking to improve on what they have, especially their helicopters. But how much of an upgrade is the Bell 360 Invictus over the earlier Bell helicopter versions? Scott Donnelly, the chief executive officer of Textron, said in 2019 that the Invictus will be based on previous technology used in the Bell 525 Relentless, an American super medium lift helicopter under development by Bell Textron. For helicopters, rotors have always been a massive talking point, as they sometimes point to the time of their design and the technology available at the time. However, the Invictus has been promised to be nothing short of a monster in the air. Although it follows the same architectural template as the Bell 525 Relentless, there are some differences. For example, the Invictus will only have seats for two, a gunner and a pilot. Also, it will use a single engine and a four-blade rotor, whereas the 525 uses twin engines and a five-blade rotor and has a 19-passenger capacity. Bell has since announced it is developing the Invictus with Collins Aerospace, and the Sierra Nevada Corporation is developing the mission systems for the aircraft. The first design was unveiled on October 1, 2019, which reflected a tandem cockpit, meaning that the pilot and the gunner would not be sitting beside each other like it is done in commercial helicopters, but in front and back seats. The design took everyone by surprise because the older version, like the AH Apache, used to have the gunner in the front and the pilot in the rear. However, the Bell 360 Invictus is a different case, owing to its advanced sensors, automation, and even situational awareness. Hence, the pilot does not have to be at the rear. The aircraft has sighting optics and a laser designator above a 20mm cannon gun turret at the chin position below the cockpit, mid-mounted stub wings under the rotor hub, and 12-meter rotor blades. The aircraft is particularly weirdly built, owing to the specifications designs from the United States military. For some context, they asked that the helicopter be able to fit in between buildings on future battlefields. As for speed, the Future Attack Reconnaissance Aircraft expects that the aircraft is able to cruise in excess of 210 miles per hour and is supported by a single General Electric T901 turboshaft engine with supplemental power from a Pratt & Whitney P207D1 turboshaft. The introduction of the Invictus is a game-changer for helicopters, especially since it replaces conventional controls like cables, pulleys, and rods with an electronic system, often referred to as the fly-by-wire system. The Invictus is the perfect lightweight helicopter since it cuts off every need for a mechanical linkage between the pilot and the control surfaces. For some context, the fly-by-wire system replaces the conventional manual flight controls of an aircraft with an electronic interface. The movements of flight controls are converted to electronic signals, and flight control computers determine how to move the actuators at each control surface to provide the ordered response. Bell Helicopter designed the Invictus as a completely fly-by-wire controlled aircraft. While the world waits in unbridled anticipation, Bell Helicopter unveiled its first full-scale mock-up of the 360 Invictus at the Association of the United States Army annual show, beginning in 2019. Although it received great attention, it was still based off the Bell 525. But what makes the Bell 525 so special? The Bell 525 was designed as a super medium lift helicopter with the ability to carry up to 19 passengers. However, its major difference from the Invictus is its global market, which was made specifically for commercial use, including the corporate, oil and gas, medical services, and search and rescue markets. But just how much does it serve as a building template for the Bell 360 Invictus? The Bell 525 was designed by Bell Helicopter to fly at a speed of around 185 miles per hour, which anyone could argue was fast enough for a conventional civilian-friendly helicopter. However, for the military, they wanted more speed, something fourth generation that breaks the speed threshold to almost 207 miles per hour. Since the Bell 525 was already on the cusp of that speed limit, it was the perfect foundation to build on for the Bell 360 Invictus. The Bell 525 was designed with a streamlined fuselage to reduce drag, while the aircraft flies in a rotor design that helps to optimize both lift and speed, two of a helicopter's most important features. Also, the fly-by-wire was a concept that was already built into the systems of the Bell 525, prompting the structural and mechanical design choices for the Bell 360 Invictus. However, the fly-by-wire was much more than just a reduced mechanical linkage from the pilot to the control surface. It is an important part of a helicopter's maneuverability owing to a trade-off in weight for agility. Although the Bell 525 is no military-grade helicopter, it was designed to trot the most difficult terrains, and so streamlined that it could take tight turns in urban and forested terrain. Also, the Bell 525 was for long-range commercial flights, including transporting executives to offshore oil rigs or meetings in the most remote areas. Hence, it was designed with some serious fuel capacity, meaning that it rarely had to stop over for fueling, even when it traveled long distances. More importantly, this translated directly to their requirements to create the monster Bell 360 Invictus for the upgraded military program. Imagine the capability to take on enemy combatants over long distances without a need to refuel. A strong way to completely change the game. Since the Bell 525 was already a machine capable of excellent control and aerodynamic superiority to match with quick responsiveness to aid yaw, pitch, and roll, while using their effective rotor systems, Bell Helicopter figured that they had a head start on building themselves a replica for the military. Hence, there was no need to start over. The future looked all good and ready for a takeover in the helicopter space by the United States Army. However, as time went on, there was rarely news making rounds about this groundbreaking helicopter, and somehow it was beginning to trail off under the radar. As expected, a government program overseen by and for the military, who are trained in the arts of clandestine relationships with the media while learning to protect state secrets, made it difficult for a non-insider to tell what was going on. However, in a country with a media as effective as the United States, even the United States military has the chance for leaked information. And this time, it was revealed that there was a possibility of the Invictus not being released into the Army, and the project could be canceled once and for all. Although the claims were chalked off as rumors, they started to gain some traction as the years progressed. After a couple of years had passed, questions were being asked, and there were no answers. Fast forward 5 years after the mock-up had been released, on February 8, 2024, the United States Army finally proclaimed the end of the Future Attack Reconnaissance Aircraft FARA program, the same program that birthed the idea of creating the Invictus in the first place. This sudden information from the United States Army gave some legs to the rumor of a possibility that the aircraft 360 Invictus might remain in mock-up stage for life and never be produced in scale or added to the military fleet of helicopters. However, after the Army Chief of Staff, Randy George, relayed the decision, he explained that the Russo-Ukraine war has given him a new and even cheaper idea on how to engage in aerial combat without spending anywhere near $1 billion. The drones are relatively smaller, cheaper, and harder to detect, owing to the infusion of cutting-edge technologies and a possible development into using artificial intelligence. The Army Chief immediately recognized it as a safer option in war. Imagine a possibility where aerial vehicles can be sent behind enemy lines unmanned, reducing the possibility or near certainty of the loss of a life if it ever gets blown out of the sky. While his reasons remain exceptionally valid, it throws the future of the United States Army into the dark pit of doubt. Although the Future Attack Reconnaissance Aircraft FARA program has been declared closed, there are speculations that the already created projects and mock-ups, such as the Bell 360 Invictus, could possibly be retained and eventually added to the fleet in 2025. Whether or not the Invictus takes a place in the United States Army's fleet, only time will tell. Modern warfare has always centered around two things: intelligence and aerial superiority. While unmanned combat aerial vehicles like the Boeing MQ-28 and Ghostbat Kratos XQ-58 Valkyrie have been the talk of recent aerial warfare technology, cutting-edge war helicopter designs have forced their way into the conversation, with Russia's recent $3 billion invention taking center stage. How does this invention shape the future of aerial combat? What makes this helicopter different from its predecessors? Let us unpack the significance of this aerial combat vehicle as Russia tests its $3 billion helicopter. The superpower countries of the world have always been at war over economic and territorial disputes, leading to the continuous destruction of lives and properties. While alliances and opinions change over the years, redirecting the brutality across the continents like a war version of whack-a-mole, one thing remains constant: inventions. War has always found a way to precipitate some of the greatest technologies in the world, especially combat vehicles on land and aerially. However, the tide has changed, and modern combat has gone well beyond force, with stealth coming into play, leading to the construction of cutting-edge aerial technologies like the Kratos XQ-58 Valkyrie, the Dassault Neuron, and the Chinese CH-7. While these warjets have gained some popularity and wide acclaim for their effectiveness in wartime, helicopters have been neglected in the grand scheme of things. The history of helicopters is dated back to the Second World War with the creation of the Fokker-Achilles Fa-223 Drac by Nazi Germany. The Fokker-Achilles Fa-223 had a single 750-kilowatt Brahmo 323 radial engine used to power two 3-bladed, 39-foot rotors mounted on twin booms on either side of the 40-foot cylindrical fuselage. The design created a wing-shaped effect, shaping up like some mechanical bird. At a top speed of 180 kilometers per hour, the Fa-223 could cruise at 175 kilometers per hour and climb to an altitude of 7,100 meters. At the time, it seemed that they had built the world's eighth wonder, as no one else had ever seen or built any such thing as a helicopter. Of course, there were biplanes like the 1935 He-49, which was primarily designed for stealth purposes. However, the invention of the Fa-223 brought about a new type of reality and changes to aerial warfare. The Nazi German army was quite impressed with the first experimental helicopter, the Focke-Wulf FW-61. However, it was not a military helicopter. It was only an experimental creation of Foch's brainchild. However, the Nazi Germany defense did not mind his avant-garde approach. They needed an aerial combat vehicle that could carry 700 kilograms of payload without a problem, leading to the creation of the Fa-223 prototypes. A fun fact about the Fa-223 is that it used to be called the Fa-226, with no specific reason given for the redesignation of the name. Owing to its status as the first of its kind, it needed to go through flight testing. First, it was taken through a tethered flight test, and then an untethered flight test on August 3, 1940. While the Fa-223 seemed to have been credited with being the very first helicopter ever made, it was halted in production by the Allied bombing that hit Nazi Germany in June 1942, when Delmenhorst, their factory base, was incessantly bombed to the high heavens during the Second World War. Hence, the production phase was hampered, and only 20 were built. Although the Fa-223 maintained its position as the first military helicopter ever built, the Sikorsky H-5 took the spotlight. While the Fa-223 was mainly designed for military use, the Sikorsky H-5 ensured the creation of a chopper that could be used by the military and also purchased by civilians. The H-5 was originally developed by Sikorsky as an S-48. However, the United States Air Force redesignated it as an R-5. The helicopter was designed to carry out certain functions, including increased payload, endurance, speed, and service ceiling, compared to its predecessor, the Sikorsky R-4. The Sikorsky H-5 was a different beast. It differed from nearly every other chopper to have ever been made. It has a beastly rotor diameter and a longer fuselage than its predecessor, the R-4. However, as Sikorsky's market grew, making a name for itself in the military airspace, a bit of capitalism set in. Hence, they decided to modify it into a version more civilian-friendly. Setting up a capitalist venture isn't too difficult to create, especially in a class-based society where the proletariat would pay over the odds to seem completely out of everyone else's league. To lean into the capitalist market, the Sikorsky S-51 was designed with a greater rotor diameter, greater carrying capacity, and an evenly shared gross weight, providing carrying capacity for 3 passengers plus the pilot. The S-51 was designed to appeal to civilians, but also to be used on military and Air Force bases. However, it became the first helicopter to be sold to a commercial user. While the military understood the difference between the commercial usage of the flight, 11 S-51s were still ordered by the United States Air Force. Also, they were redesignated as the R-5F, and 92 of them were sent to the Navy as the HO-3S1, commonly referred to as the Horse. The Navy ordered 4 S-51s from Sikorsky in late 1946 and used them during Operation High Jump. However, the S-51s were placed into the inventory as HO-3S1. It was stealthily ferried across the seas using the seaplane tender USS Pine Island, or AV-12, as popularly called. The helicopter, first flown by Lieutenant Commander Walter M. Sessoms, became the first ever helicopter flight across the Antarctic. However, as time went on, warfare evolved, requiring an improvement in the invention of helicopters. While the S-51 had enough modifications to be both a commercial and military plane, it had more military ramifications. During Operation High Jump, it was used as a utility helicopter for rescue and mercy missions throughout the world, highlighting questions if it should have been allowed for commercial use in the first place. While the United States dominated the helicopter space with Lockheed Martin and Sikorsky, a global arms race loomed in the air like a dark cloud, and the world's superpowers followed suit, especially the United States' biggest counterpart, Russia. While early helicopter development has been through different phases of creation and versions, Igor Sikorsky remains one of the most important shapers of the modern helicopter industry. However, as his name might suggest, he was never American. He is a Russian man who fled the country during the Bolshevik Revolution, seeking new opportunities in the United States. And just like that, the Russians lost a super inventor to the United States, owing to an instability in their government. Although Russia lost Igor to the United States, they weren't fazed by the success of his invention, as they believed that they could do the same. Hence, while Igor built his choppers in the United States, Russia reacted with a chopper of their own, the Mi-1. This is Russia's first helicopter to ever make it into mass production, developed by Mikhail Mil. Before 1930, Mikhail Mill had been working on a winged aircraft that used rotation to propel its locomotion. However, a good dream is determined by planning. Mill put a lot of work and planning into the design, but he kept failing until 1946. His first designation was the EG-1, after becoming the head of the OKB-4 Design Bureau in Toshino, Russia. While he created his helicopter and failed many times, he finally figured it out. He created a final design called the GM-1, translated as Gelikopter Mila, or Mill's helicopter in English. While the Sikorsky version tried to entertain more strength, dexterity, and complex rotor movement, the Soviet engineers opted for more simplicity, increasing efficiency in helicopter control, unlike the American choppers. To achieve this efficiency, they made a rotor hub with spaced vertical and horizontal hinges. The first prototype completed its first untethered flight on the 20th of September, 1948, piloted by Mikhail Babalov. While the test was a success, the Russian military demanded an official state trial, so Mikhail agreed to their demands, and they launched their trial in 1949. During testing, 2 prototypes of the helicopter were crashed. However, Mikhail did not give up. He put in a bit more work than usual, made a few tweaks, and found an answer to the reasons for the crash. The success of his work not only gave him worldwide plaudits, but the Russian military placed a demand for his chopper, albeit under a new designation called the Mi-1 for Mill initials. While the production was initially limited to a series of only 15, ordered on the 21st of February, 1950 in Factory Number 3 in Moscow, production was not increased until 1951, when Joseph Stalin witnessed the helicopter in action and deemed it important to their warfare. The 1950s saw the growth of rotor technology, hence the Mi-1s were redesigned for increased reliability, especially the number of hours it could spend in flight. First, they created the Mi-1T, with the T representing Treksochasovoy, translating to 300 hours in English. Then rotor capacity improved even further over the year, with another 300-hour improvement in the Mi-1A, and then to 1,300 by the end of production. While the Mi-1s were initially built for carrying cargo and capability to play bit parts in stealth, they figured that they could do more with a different variant that could carry even heavier payloads and operational equipment, including full radio and bind flying instruments, and utilized a more reliable engine, the AI-26VF, hence the release of the Mi-1T than the Mi-1A. However, as technology improved, the Russian defense was no slouch either. The early 60s saw the introduction of enlarged cabins and engines even more powerful and reliable than the AI-26VF, which allowed the accommodation of 3 passengers on a bench behind the pilot. Russia at the time anticipated war, and they wanted every air superiority that they could possibly have over their adversaries. So they opted for the production of a rather distinct version of the Mi-1s at the time, designating it the Mi-1Mu. The Mi-1MU was specifically designed as an anti-tank helicopter. The rationale behind it wasn't too difficult to understand. Talking about defenses against a chopper, an armored tank, and surface-to-air missiles could definitely do the job. Hence, in 1961, when Russia looked casually for a counter against tanks and surface-to-air missiles, they created the first Soviet attack helicopter. While reports suggest that they had a really good trial run, for some reason, it wasn't accepted into the production stage. The trading rumor at the time was that it had a small payload capacity and that just wouldn't do the trick for the Soviet army. Although the Russians had responded positively to the United States helicopter production with some of their own, they were in for another rude awakening when America released a completely different beast of a helicopter in 1962, the Bell AH-1 Cobra. The Cobra was created in response to the United States Army's request for an interim gunship during the Vietnam War, and it used the transmission and rotor system of the Bell UH-1 Iroquois, which had already proven itself to be a capable platform during the conflict, but paired it with a redesigned narrow fuselage among other features. It was the perfect combat helicopter. It was equipped with stub wings used to anchor various weapons, a chin-mounted gun turret, and an armored tandem cockpit, meaning the pilots were seated one behind the other. It was shaped in a very slender figure for agility, almost reminiscent of a cobra. Also, the slim shape makes it difficult and, in some cases, nearly impossible to get hit by tanks or surface-to-air missiles, except there is some form of pinpoint accuracy to hit the chopper. Its first appearance came through during the Vietnam War, in June 1967 to be precise. It provided fire support to friendly ground forces. In some sort of ways, it was like calling in the cavalry. Its effectiveness was almost dreamy, as no one really knew how capable it could be. Often it was paired with the Hughes OH-6 Cayuse, a single-engine light helicopter designed and produced by the American aerospace company Hughes Helicopters. While the Cayuse performed its stealth and scout mission, gathering intelligence, the Cobra followed closely like a guard dog, shooting to eliminate any form of threat in its way. The tag team operation was referred to as the Hunter-Killer mission. The Cayuse played the hunter, and the Cobra played the killer. The Cobra became the talk of aerial warfare all over the world, with an unprecedented effect on aerial combat. While one might think of the United States hoping to hoard such military might, surprisingly, they were ready to sell. And nations such as Israel, Turkey, and Japan reached out to buy, increasing their military might with the United States' cutting-edge technology. While warjets keep getting accolades for their service in war, as in good reasons, the Cobra AH-1 also became a fundamental part of some of the greatest wars ever fought in the name of the United States. Aside from the Vietnam War, the Cobra dealt devastating blows in Vietnam, Grenada, Panama, and the Gulf War. However, as time went on, scientific evolution caught up with the Cobra, leading to the creation of its replacement, the Boeing AH-64 Apache, during the 1990s. Although the Cobra might have been a United States creation, it was also used prolifically by the Israeli Air Force, who used it for combat during the Lebanon War of 1972, giving them an edge in the war. Upgraded versions of the Cobra have been developed, such as the twin-engined AH-1C Cobra, otherwise called the Super Cobra, and the experimental Bell 309 King Cobra. Although the Cobra seemed like the peak of modern combat helicopters at its inception, it eventually became surplus to requirements and has been reused for other purposes, including civilian ones. Numerous examples have been converted to perform aerial firefighting operations. A perfect example is the United States Firewatch Services, which acquired Cobras that have been used in combats during the Vietnam Wars and retrofitted them into a red-white perfection with infrared sensors, so they can be used to gather close-in intelligence from ground troops fighting fire. While the world watched the slim Cobra showing off at war and eventually retiring as a firefighter outfit, other world superpowers looked to create a better version of this combat monster. While some have tried and failed at the production level, Russia has come up with a $3 billion helicopter project that has left the military combat landscape in awe. The Russian military had always had a trusted template for their helicopters, Mikhail Mills. After his discovery in the 40s through the cities, the Russian military fell right in league with world superpower countries that possessed a combat helicopter. However, while that time may have well passed, the Mi-17, introduced in 1975 as the Mi-M8, resumed production in 2024 at factories in the Kuzan and Ulan-Ude. While some might have an idea of this chopper's capabilities, it has been stepped up to a whole new level, and no one saw it coming. Of course, it isn't news that Russia remains at war with Ukraine. It would seem another time of war has created another cutting-edge technology in aerial warfare, a recurring theme in the history of warfare. The original version of this chopper was built from the basic Mi-8 frame, fitted with larger Klimov TV3 engines, rotors, and transmission, along with fuselage improvements for extra heavy load capacity. While most choppers struggle with hot and high conditions, where there is a low air density due to high ambient temperature and high airport elevation, and air density decreases with increasing temperature and altitude, Russia's new $3 billion Mi-17 is equipped with optimal engines like the 1,545 kilowatt Isotov TV3117VM to battle these conditions easily. Although Russia has a reputation for keeping its military intelligence a secret and unleashing it unexpectedly in combats, it has decided to export the Mi-17s, flexing its newfound military might and them sending a message of caution and protection. The helicopter has a specific design that has kept it completely different from every other kind. Its recognizable trademark is the tail rotor added to the port side instead of the conventional starboard side and dust shields in front of the engine intakes. The production sent a shockwave down the spines of competitors around the world, not only sparking a global arms race, but buyers queuing at Russia's door, banging on for a chance to buy this super air beast. In March 2001, Russia eventually gave China a license for production, albeit led by Mil Moscow Helicopter Plant JSC and the Sichuan Lantian Helicopter Company, limited in Chengdu, Sichuan Province, as a joint venture. Fast forward to the 21st century, and countries like Argentina, Bangladesh, and Peru have come as clients looking to buy this helicopter in an arms deal worth millions of dollars to Russia. While the military and economic tussle between Russia and the United States remains a reference point, it has never stopped them from doing business even in arms, where both countries appear to be the leading light. Their first buy from the Russian military came in 2009, and they handed over 4 of the cargo helicopters to the Pakistan Army to facilitate its counter-terrorism operations, while they played big brother in their diplomatic relations with Pakistan. However, not only has the United States used this Russian state-of-the-art helicopter for diplomatic reasons, they have also reportedly considered adding it to their special forces ranks, using it to obscure troops' movements. Fast forward to 2022, the Joe Biden administration announced that the United States would be supplying Ukraine with 11 Mi-17s to aid them in their defense against Russia. Imagine a capitulation of Russia under its own $3 billion cutting-edge technology. High above the Red Sea, the Houthis made a bold move, firing at what they thought was an easy U.S. target. But it was no ordinary aircraft. It was top-tier American tech. What followed was swift, overwhelming firepower. That single mistake may have turned the tide, shaking their confidence and shifting momentum in a conflict that's been heating up for years. So what exactly happened in that fateful encounter? What kind of helicopter did they target? And why has this become a global military lesson in tactical failure? Join us as we uncover how the Houthis attacked the wrong U.S. helicopter and the enormous fallout that followed. In the early morning hours of December 2024, around 6:30 a.m. local time, 2 U.S. Navy MH-60R Romeo Seahawks, advanced multi-role helicopters launched from the aircraft carriers USS Eisenhower and USS Gravely, were flying protective cover over a naval convoy, cruising through the tense waters of the southern Red Sea. Up to that point, the patrol had been uneventful, almost routine, but that calm wouldn't last. Unbeknownst to the Seahawk pilots, a group of fast attack boats operated by the Houthis, an Iran-backed militia based in Yemen, had been silently shadowing the convoy near the port city of Al-Hudaydah. Their target, a high-value commercial vessel. These weren't your typical pirates. The Houthis are known to use guerrilla-style naval tactics, blending speedboats, drones, and guided missiles, often supplied or modified using Iranian technology. Suddenly, the silence was broken. The Houthis launched a coordinated assault, firing off a wave of guided rockets and spraying machine gun fire at the Maersk Hangzhou, a massive container ship flying under the Singapore flag. The ship was steaming through international waters, about 55 nautical miles southwest of Al-Hudaydah, right in a region nicknamed the Red Sea Choke Point, one of the world's busiest and most vulnerable shipping lanes. Their plan was dangerously straightforward. Swarm the vessel with speedboats, storm aboard before the crew could even react, and take over the ship. This tactic, called a wolf pack maneuver, is designed to overwhelm a target through sheer numbers and chaos. What made it even more alarming is that the Maersk Hangzhou wasn't just carrying consumer goods. It was also believed to be hauling critical components for global tech supply chains. Interestingly, the MH-60R Seahawk helicopters used to defend ships like this aren't just armed with torpedoes and missiles. They're also equipped with sophisticated sensors that can detect threats on, above, and below the water, like small boats trying to hide in radar shadows or underwater mines. The Seahawk's ANAPS-153 radar can track dozens of fast-moving targets simultaneously, even distinguishing small boats from ocean waves. This ambush wasn't just another piracy incident. It highlighted a growing and dangerous trend: the increasing militarization of non-state actors at sea. There was just one big problem. 2 U.S. Navy helicopters were already in the air, flying straight toward the danger zone. These weren't just any helicopters. They were MH-60R Seahawks, the Navy's go-to aircraft for hunting submarines, scanning the seas and tackling unexpected threats. They had taken off from 2 powerful ships, the aircraft carrier USS Dwight D. Eisenhower and the guided missile destroyer USS Gravely. Their call signs? Lancer 71 and Lancer 72. Names that sound like something out of a Tom Clancy novel, and for good reason. At first, the mission was pretty routine, just keeping an eye on nearby ships, providing security, and checking out anything fishy. Nothing out of the ordinary. But that all changed in a heartbeat. Instead of a quiet patrol, these Seahawks suddenly found themselves flying right into a real-life maritime emergency. A full-blown hostile boarding attempt on a U.S.-escorted cargo ship called the Maersk Hangzhou. This wasn't just any freighter. The Maersk Hangzhou is part of the Maersk Line, one of the largest shipping companies on Earth, moving goods worth billions across oceans every year. When things started to go south, the ship's crew quickly sent out a distress call, and that's when things got seriously intense. Hangzhou wasn't defenseless. On board was a small private security team from a company called the Trident Group, a firm started in the late year 2000s by former Navy SEALs to protect ships from pirates, especially around the dangerous waters near Somalia. These security teams aren't allowed to carry heavy-duty weapons like naval guns or missiles. The Trident Group guys were armed with just M4 carbines and a single M240 machine gun. The attackers? They were Houthi rebels, speeding in on fast boats and packing much heavier firepower, likely rocket-propelled grenades and mounted machine guns. As they closed in, within about 6 nautical miles, or around 7 miles, the security team jumped into action, taking positions on deck and preparing for a possible shootout. It was a heart-pounding moment where every second counted. What started as just another watch over the sea turned into a life-or-death showdown. The kind of moment where training, courage, and the right kind of backup could mean the difference between disaster and survival. The Houthis weren't just armed, they were packing some serious firepower. They had rocket-propelled grenades fitted with thermobaric warheads, which are extremely deadly because they create a massive pressure wave that sucks the oxygen out of the air before igniting it, a fiery vacuum explosion. They also carried belt-fed PKM machine guns, a Soviet-era weapon known for its range and brutal reliability in harsh conditions. All of this gave them a clear edge over the merchant ship, which had little to no means of defending itself. Within minutes, the Houthis in their fast-moving boats were about to pull up right alongside the vessel, preparing to board it, likely with force. But help was already on the way. 2 U.S. Navy MH-60R Seahawk helicopters responded the instant they got the green light. These birds are equipped with advanced radar, Hellfire missiles, and even torpedoes, though they're usually used for hunting submarines. But this time, they were heading into a surface battle. They raced through the sky at 160 knots, roughly 185 miles per hour, to cover the 26 nautical mile gap between them and the endangered merchant ship. But even at that speed, they'd need about 9 minutes to get there. And the Houthis only need 4 to 5 minutes to reach and possibly hijack the ship. That meant the pilots had to act fast and hit hard before it was too late. At exactly 29 minutes to 7 a.m., their radar lit up. 4 fast attack boats were closing in tight on the Maersk Hangzhou. These weren't just any boats. They were Iranian-supplied Boghammer-style speedboats, small, fast, and deadly. Originally a type of Swedish civilian boat, Boghammers were repurposed by Iran in the 1980s to fight Iraqi naval forces during the tanker war. They're compact, but capable of reaching up to 50 knots, nearly 60 miles per hour on water, and they were coming in fast, moving in a tight formation designed to overwhelm defenses. These boats are often rigged with heavy machine guns, grenade launchers, or even small missile systems. And because of their speed and size, they're notoriously hard to hit. With just moments to spare, the Romeo pilots began coordinating a precision strike that could knock the boats out before the Houthis made it to the side of the ship. The fast-moving Boghammer speedboats, each carrying around 3 or 4 Houthi fighters, weren't just cruising around. They were seriously armed and ready for battle. They had some heavy-duty gear, including PKM machine guns, AK-47 assault rifles, and RPGs. But not just any RPGs. These were the thermobaric Taba-14, a real game-changer. These RPGs are designed to tear through up to 300 millimeters of rolled homogeneous armor, the same kind used on tanks. For context, that's like a giant, high-powered cannonball aimed at a tank's armor. Now think about the hull of a massive commercial ship like the Maersk Hangzhou. It's only about 25 millimeters thick, which is thinner than some of the metal used in bank vaults. These speedboats weren't just speeding in blind. They were equipped with Starlink satellite terminals. This was no ordinary attack. They had live video feeds and data streaming back to Houthi command centers in Hodeidah, a coastal city they control. It was like they had eyes in the sky, as drones buzzed overhead, sending updates about the ship's movements. Add to that spotters along the coastline and command units tracking everything, and it's like they were playing a high-stakes video game, directing their boats with precision from multiple angles. The attack strategy wasn't just random chaos, it was modeled after Iran's naval playbook, particularly their famous swarm tactics. This strategy is all about overwhelming bigger, slower ships with a swarm of smaller, faster boats attacking from different directions at once. It's something Iran's been practicing for years in the Persian Gulf, using cheap, fast boats armed to the teeth. Even though the Maersk Hangzhou was a civilian cargo ship, it wasn't entirely defenseless. As the boats closed in, about 1,800 meters away, just over a mile, the ship's security team sprang into action. They opened fire with M240 Bravo machine guns, mounted in reinforced positions on the rear and left side of the ship. These 7.62 millimeters belt-fed weapons are widely used by NATO forces and can unleash a deadly barrage of bullets. In a heart-pounding standoff, the ship's security team managed to damage one of the enemy boats. But they couldn't stop all 4. In just 47 seconds, the attacking boats were a mere 600 meters away and closing in fast. With each passing moment, the threat of RPGs being launched grew stronger, making the situation even more dangerous. The crew had to act quickly. One of the attackers' boats took a heavy hit when their rudder was completely disabled by the ship's suppressive fire, temporarily putting them out of action. But just as the tide seemed to turn, the RPG gunner from Boat 2 fired, and the rocket flew dangerously close, only about 3 meters from the ship's superstructure. This was the most critical part of the ship. The superstructure, which rises above the main deck, contains vital control rooms for navigation and defense. If it were hit, the ship could lose its ability to maneuver or coordinate any defense, leaving it vulnerable to a full-on attack. As the enemy boats hovered at 600 meters, preparing for that final, deadly strike, the tension was unbearable. It seemed like the ship's security was on the brink of being overwhelmed. But just when things looked bleak, the cavalry arrived in the form of Seahawk helicopters, the unsung heroes of naval operations. These helicopters, known for their speed and deadly accuracy, swooped in at just the right moment. The ship's relentless defense kept the attackers within range, allowing the Seahawk pilots to neutralize the threat before it escalated further. The delay gave the Lancer 71 and 72 just enough time to close the distance, and by 21 minutes to 7 a.m., they were only about a mile away. With Romeos cleared for action, the only task left was to figure out which boats to target first. Positioned just beneath the aircraft's nose was the ANPS 153V radar. This radar system is incredibly advanced, with capabilities far beyond what most people imagine when thinking about radar technology. It had already detected all 4 boats from 42 kilometers away, but due to the dense sea clutter caused by waves, marine life, and even distant ships, it couldn't provide an accurate reading right off the bat. At that moment, the radar was tracking 32 separate contacts in the area, each representing something in the water, but not all of them were necessarily threats. The pilot, knowing the importance of precision, quickly switched the system to narrow pulse mode. In this mode, the radar sent out rapid pulses of energy at intervals of just 0.5 to 1 microsecond, which allowed it to filter out irrelevant signals and get much clearer, higher resolution data. This was crucial for separating real targets from environmental noise, especially in a combat zone where every second counts. What's particularly remarkable about this radar is its ability to operate in sea clutter, which has always been one of the most challenging environments for radar systems. Typically, sea clutter would scatter radar waves, making it harder to track smaller objects like boats. But the ANPS-153V is designed to overcome that. The system is also capable of switching frequencies and using advanced algorithms to continuously improve its targeting accuracy. This radar's versatility is what allows it to be effective in situations that would otherwise confuse or mislead conventional radar systems. In narrow pulse mode, the radar can gather precise data not just about the boat's position, but also its speed, course, and profile, essentially creating a digital snapshot of the target's movement. This was what allowed the Romeos to adjust and lock onto the correct boats. The radar's ability to see through the clutter was made possible by its very high frequency range, which also provides more detailed readings of smaller objects. Once the radar data was processed, the Romeos were able to fly directly over the top of the Houthis boats, confidently targeting them for the next stage of the operation. This APS-153 radar is equipped with a clever feature called the Moving Target Indicator, and it works in a pretty cool way. As a target moves, the MTI takes advantage of Doppler shifts, the same effect that happens when you hear the sound of a motorcycle speeding by. As the motorcycle approaches, the pitch of the sound changes. This is the Doppler effect at play. The radar does something similar, but with radio waves. As the target moves, it picks up on these subtle changes in frequency, and from there, it can figure out if it's a solid object in the water or just a passing wave. And it's almost like radar has ears for radio waves, listening for that same pitch shift. Once it picks up on the shift, the radar knows there's something more than just water. Then the pilot switches over to a technique called inverse synthetic aperture radar, which uses the Doppler shifts to build a high-resolution image of the target. This method is so precise that the radar can produce a real-time image of a moving target, allowing pilots to confirm the exact details of what's in their sights. The cool part is that this isn't just a typical radar system. The ISAR radar gives such detailed, sharp images that it can even distinguish between different types of targets in the water. Pilots can spot a boat from a distance and confirm if it's a military vessel, making it incredibly valuable for operations that require pinpoint accuracy. This tech is a big deal because it works in real time and can track moving objects across vast distances, even in challenging weather conditions or at night. Radar systems like this are often used in military operations to identify and track targets across oceans, a critical advantage when someone can't always rely on visual spotting. So once the radar confirms a moving target with all these detailed images, the pilots can lock in on the target and proceed with their mission, knowing exactly what they're dealing with. Each Seahawk helicopter was equipped with two powerful GAU-21, 50 caliber machine guns, one on each side. These guns weren't just for show. Each one could unleash up to 1,100 rounds per minute. That's a staggering rate of fire that would make any target think twice. With a maximum effective range of 1,850 meters, these machine guns were designed to pierce through tough armor and thin-skinned boats alike. The rounds they fired were a lethal mix of armor-piercing incendiary and tracer rounds, specially made to punch through targets with ease and leave a fiery trail behind. But the real action began when the Hoodies, a group of aggressive small boats, fired the first shots at the helicopters at around 640 meters. The Hoodies' PKM machine gun tracers zipped past the Seahawks, some barely missing within just 15 meters. This was a huge mistake on their part. The Seahawks, quick to react, immediately dropped down to 150 feet, a maneuver that turned the tables. It was time to strike back. In addition to their rapid descent, the Seahawks deployed an array of high-tech countermeasures. Each helicopter released 12 MJU-68B flares and 24 RR-180 chaff bundles into the air. These weren't just for show either. When combined, they created a cloud of infrared and radar reflections behind the helicopters, confusing enemy sensors and making it almost impossible for the boats to lock onto their targets. These countermeasures were crucial for avoiding enemy missiles, and they worked flawlessly. When the crew suspected the Houthis might fire an IRG-guided missile at them, they didn't hesitate. They launched flares instantly. These weren't your average fireworks. These flares burned at an incredible 2,200 degrees Celsius, hot enough to melt steel, and stayed lit for almost 2.5 seconds. That's more than enough time to fool any heat-seeking missile, especially shoulder-fired ones like man-pads. These flares are made from special materials like magnesium and Teflon, which not only burn extremely hot, but also release infrared radiation that tricks the missile's heat sensors into locking onto the flare instead of the aircraft. Some modern flares even pulse at specific frequencies to imitate jet engine signatures, making them even harder to resist. Even though no missile launch was confirmed, the pilots weren't about to gamble with their lives. Then at exactly 19 minutes to 7 a.m., everything changed. Lancer 71, the lead attack helicopter, locked onto Boat 1. The door gunner unleashed 3 short bursts of 50 caliber machine gun fire. These aren't ordinary bullets. A 50 caliber round is as long as a toothbrush and can punch through engine blocks, light armor, or even concrete walls. The rounds ripped through the boat's engine like paper and struck its fuel cell. Within moments, the boat erupted into a fiery explosion, hurling burning fragments into the sky like a volcano. In just 45 seconds, the vessel was swallowed by the sea. But Lancer 71 wasn't done. Before the first boat even disappeared below the waves, the chopper pivoted left and locked onto Boat 2. A quick burst hit the rudder dead on, crippling its ability to steer. Then for a full 3 seconds, the gunner opened up again, laying down a steady stream of lead that left the boat spinning helplessly in the water. The situation unfolded quickly and violently. At 18 minutes to 7 a.m., the boat listed heavily, filled with water, and capsized. In mere moments, both helicopters shifted their attention to the boats, zeroing in on the third one. This boat didn't stand a chance. It was caught in a double attack, with both helicopters firing relentlessly. Within seconds, dozens of armor-piercing rounds tore into the boat's hull, puncturing holes below the waterline. The crew scrambled, trying to bail out the water, but it was a losing battle. By 16 minutes to 7 a.m., the boat had disappeared beneath the surface, sinking to the depths. The helicopters didn't waste time. They switched targets, focusing on boat number 4. But the crew of this boat had seen enough. Watching their comrades sent to the ocean's depths, they immediately turned tail and fled. They headed northwest, leaving a trail of smoke behind them as more rounds slammed into their boat. Despite the assault, the Seahawks didn't pursue. They had to remain focused on the merchant vessel they were protecting. In under 7 minutes, the 2 helicopters had sunk 3 boats, firing roughly 1,800 rounds in the process. That's a rate of about 4 rounds per second. But the retaliation wasn't over yet. The Houthis would soon find out that their attack on U.S. forces was far from being the last word in this exchange. Interestingly, military tactics like this one are not always about overwhelming force. For example, helicopters are often used not just for firepower, but for their mobility and precision in complex combat scenarios. It's also worth noting that in these kinds of operations, the use of armor-piercing ammunition is critical. It's designed to penetrate through tough materials like steel or other hardened surfaces, perfect for stopping boats and other vehicles in their tracks. The U.S. Central Command quickly realized that just sinking a couple of Houthi boats wasn't going to be enough. They wanted to make sure the Houthis felt the full weight of their response and learned not to repeat their mistake. So within just 8 hours of the initial attack, the Navy swung into action. The USS Gravely was sent in to take the lead. Instead of going after more boats, this time they targeted the Houthis' eyes and ears, their coastal radar stations. These radar sites are critical for the Houthis, as they're used to track ships moving through the Red Sea and guide their explosive-laden drones and fast boats toward high-value targets, including commercial and military vessels. Armed with its powerful 5-inch Mark 45 Mod 4 naval gun, the Gravely let loose a storm of firepower. It fired a total of 92 rounds, each shell weighing about 70 pounds and capable of exploding in midair to scatter shrapnel over a wide area. These advanced shells are designed for maximum impact against both people and equipment. They can fly at speeds over 2,600 feet per second, fast enough to cover a football field in less than a tenth of a second, and can hit targets as far as 9 miles away, even while the ship is moving. But what made this strike stand out was how smoothly and boldly it was executed. The Gravely cruised along the Yemeni coastline, striking targets with pinpoint accuracy. It faced little to no resistance, showing just how advanced U.S. naval technology and training are. One by one, 3 major Houthi radar installations were destroyed: Jabal al-Tayr, al-Mocha, and Ras Isa. Over the past 2 weeks, the Houthis had been secretly using several hidden locations to keep an eye on coalition ships sailing through the Red Sea. But that plan started to fall apart quickly. After a series of targeted attacks, U.S. drones confirmed that about 60% of the Houthis' maritime surveillance system had been wiped out. Their ability to track ships was severely damaged, and the response didn't stop there. On January 1st, 2025, the U.S. launched a powerful follow-up strike. 4 F/A-18E Super Hornets from the VFA-131 Squadron, flying off the aircraft carrier USS Eisenhower, took off with a deadly load. Each was armed with an AGM-154C Joint Standoff Weapon, or JSOW for short. These aren't just ordinary missiles. Each one carries a 500-pound warhead with a molten metal core that can burn through nearly 4 meters of reinforced concrete at a blistering speed of 14 kilometers per second. That's more than 40 times faster than the speed of sound. Their target, the Al-Durahimi Missile Warehouse, a key storage hub for the Houthis' high-tech weapons. At exactly 17 minutes to 7 p.m. local time, all 4 missiles slammed into the site, triggering massive secondary explosions. These weren't just fireworks. Radio chatter intercepted from the Houthis confirmed that 18 of their CASF drones were destroyed, along with 4 advanced Nor anti-ship missiles, several guidance systems, and most notably 2 Iranian military advisors who were helping the Houthis, along with 12 of their operators. What made this strike different was the message behind it. It wasn't just about self-defense anymore. The U.S. showed it was ready to strike back hard and then keep hitting even after the initial threat was over, to make sure groups like the Houthis think twice before launching any more attacks. Russian helicopters have long been a force to reckon with, dominating battlefields and harsh environments alike. From the rugged Mi-24 Hind to the heavily armored Ki-52 Alligator, these machines are built for extreme conditions and brutal combat. But do they really stand out against their American counterparts? If yes, is it their superior design, firepower, or sheer battlefield adaptability that sets them apart? Join us as we explore why Russian helicopters are believed to be ahead of American. Helicopters have been a very important part of both Russia and the U.S. military missions for decades, offering unmatched versatility in combat, transport, and rescue. The story of the U.S. helicopters began in the 1930s with early designs that paved the way for today's powerful aircraft. Over the years, U.S. military helicopters have become more advanced, built to withstand extreme conditions like deserts, jungles, and war zones. Now, U.S. helicopters are packed with advanced technology, making them faster, deadlier, and more precise. The Black Hawk is known for transport and rescue missions, while the Apache is a fearsome attack helicopter loaded with advanced weapons. However, some experts claim that Russia's helicopters, especially those built by Russian helicopters, are far ahead in performance and technology. Russian models like the K-52 and Mi-28 are praised for their armor, firepower, and ability to operate in harsh environments. But does this mean Russia has truly taken the lead? And how close to the truth is this claim? Let's get into it. Helicopters first appeared as military tools in the 1930s, with both Germany and the United States exploring their potential. These early flying machines were quite different from the advanced helicopters we see today, but they laid the foundation for modern military aviation. Germany took an early lead with the Heinkel 49, one of the first military helicopters. It was mainly used for reconnaissance, helping spot enemy movements from above. This marked the start of helicopters playing a role in warfare. More German designs soon followed, including the Flettner FL-282 Colibri and the Focke-Wulf FW-61. These helicopters were small and fast, with the ability to hover and move in tight spaces, making them useful for specific missions during World War II. However, their service was limited due to wartime production challenges. On the other side of the Atlantic, the United States was also working on helicopter technology. The Vought Sikorsky VS-300 was a key breakthrough. This helicopter had multiple engines and introduced design features that influenced future models. It led to the creation of the Sikorsky XR-4, which became the first helicopter to be mass-produced for the U.S. military. The XR-4 proved that helicopters could be reliable tools for combat and support operations, pushing the U.S. to invest more in rotorcraft technology. Meanwhile, Britain also recognized the value of helicopters. The British military used hoverfly helicopters for rescue missions during the Second World War, helping recover downed pilots and injured soldiers. These early rescue operations demonstrated how helicopters could reach places that traditional aircraft could not. After the Second World War ended, helicopter technology rapidly improved. One of the most important developments was the YH-13 SU, which played a crucial role during the Korean War. This helicopter became famous for medical evacuations, quickly transporting wounded soldiers from the battlefield to hospitals. The ability to airlift injured troops in a matter of minutes saved countless lives and changed the way wars were fought. These early helicopters were just the beginning. Over the years, military helicopters became more advanced, with better speed, firepower, and durability. What started as small experimental aircraft soon became an essential part of modern warfare. After World War II, helicopters quickly became more advanced, especially during the Korean War. This war showed just how useful helicopters could be, especially for moving troops and rescuing wounded soldiers. Instead of relying only on traditional transport methods, the military now had fast, flexible aircraft that could land almost anywhere. Helicopters saved countless lives by carrying injured soldiers from the battlefield to hospitals in record time. During this period, several important helicopters were developed, each serving a unique purpose. The Bell H-12 SU was a light helicopter mainly used for reconnaissance, helping soldiers scout enemy positions. The Sikorsky H-5 played a crucial role in rescue missions, proving its worth by pulling injured troops out of dangerous situations. The Hiller OH-23 Raven was another scouting helicopter, small and quick, perfect for gathering intelligence. Meanwhile, the Sikorsky H-19 Chickasaw was much larger and capable of carrying heavy loads, making it ideal for transporting soldiers and equipment. After the war, helicopters became even more specialized. Engineers started designing helicopters for very specific tasks. One example was the Westland Wasp, a helicopter built specifically for hunting submarines. This was a game-changer for naval forces, allowing them to detect and attack enemy submarines more effectively. It wasn't just the military that saw the value of helicopters. Civilian helicopters also played a big role in shaping future designs. The Sikorsky S-51 and Bell 47 were among the most famous, used for things like medical transport, news reporting, and even agriculture. These helicopters introduced turbine-powered engines, which made them faster, stronger, and more reliable. The success of these civilian models influenced military engineers, leading to even better designs for combat helicopters. The Vietnam War is often seen as the most iconic period for military helicopters, thanks to the Bell UH-1 Huey. This helicopter changed warfare forever, becoming a symbol of the conflict. It was used to transport troops, carry supplies, and rescue wounded soldiers from the dense jungles of Vietnam. Before helicopters like the Huey, moving soldiers and evacuating the injured took much longer and was far more dangerous. But with the Huey's ability to land in tight spaces and take off quickly, military tactics changed completely. The U.S. Army could now deploy troops rapidly and provide medical help faster than ever before. The Vietnam War also introduced another game-changing helicopter, the Bell AH-1 Cobra. This was the first helicopter built specifically for attacking enemy forces. While the Huey focused on transport, the Cobra was designed for combat, armed with powerful guns and rockets. These helicopters showed the world how helicopters could dominate the battlefield, and their success shaped the future of military aviation. After the Vietnam War, military helicopters continued to improve, especially during the Cold War. As tensions between the U.S. and the Soviet Union grew, the need for better helicopters became more urgent. The military needed helicopters that could move faster, carry heavier loads, and handle more dangerous missions. One of the most important helicopters to emerge during this time was the AH-64 Apache. Introduced in 1984, the Apache was a powerful attack helicopter, packed with advanced weapons, night vision technology, and strong armor. Unlike earlier helicopters, the Apache could target enemies with precision and survive in intense battle conditions. Even today, it remains one of the deadliest military helicopters in the world. Another major advancement was the UH-60 Black Hawk, introduced in 1979. This helicopter became a key asset for the U.S. military, used for transporting troops, evacuating the wounded, and delivering supplies. The Black Hawk was faster, more durable, and more versatile than previous transport helicopters, making it a crucial part of modern military missions. For carrying heavy loads, the CH-47 Chinook, introduced in 1962, became the go-to helicopter. With its twin rotors, the Chinook could lift massive amounts of cargo, making it essential for moving supplies, vehicles, and even other helicopters. It was particularly useful in tough terrains where trucks or planes couldn't reach. These helicopters weren't just improvements. They completely changed how wars were fought. With better technology, stronger firepower, and improved mobility, helicopters became a key part of military operations. Whether in combat, rescue missions, or transporting equipment, they proved to be irreplaceable. Today, these Cold War-era helicopters are still in use, constantly upgraded with the latest technology. Their impact on warfare is undeniable, and as military technology continues to advance, helicopters will remain a critical force on the battlefield. The U.S. military depends heavily on helicopters, with about 5,500 currently in service. These aircraft are essential for a wide range of missions, from transporting troops to launching attacks on enemy targets. With 317,000 personnel in the Air Force alone, helicopters is important in moving soldiers, supplies, and equipment quickly and efficiently. Their ability to take off and land without runways makes them ideal for operations in remote or dangerous areas. One of the most important helicopters in the U.S. military is the UH-60 Black Hawk. This helicopter is mainly used for transporting troops and carrying out medical evacuations. Its reputation for being tough and dependable makes it a key part of combat missions. The Black Hawk can operate in a variety of environments, including deserts, jungles, and urban battlefields, providing critical support to soldiers on the ground. In addition to troop transport, it is also used for search and rescue missions, disaster relief, and special operations. For heavy lift operations, the CH-47 Chinook is the military's top choice. This helicopter is designed to carry large amounts of cargo over long distances, making it essential for supplying troops and moving equipment. Its twin-rotor design gives it incredible lifting power, allowing it to transport everything from ammunition and supplies to vehicles and small boats. The Chinook's ability to carry heavy loads makes it invaluable in both combat and humanitarian missions. It has been used in disaster relief efforts around the world, delivering food, water, and medical aid to those in need. The U.S. military also relies on attack helicopters to provide firepower during combat missions. The AH-64 Apache is the most powerful attack helicopter in service, armed with radar-guided missiles, a 30mm chain gun, and advanced targeting systems. This helicopter is built for combat, capable of striking enemy positions with pinpoint accuracy, even in bad weather or at night. Its advanced sensors allow pilots to detect and engage threats from long distances, giving the military a significant advantage on the battlefield. The Apache has proven itself in numerous conflicts, including Iraq and Afghanistan, where it has been used to destroy enemy tanks, bunkers, and vehicles. The O-58 Kiowa was once a key reconnaissance helicopter, but it has been phased out of most roles. However, it is still used in limited operations, where its ability to gather intelligence remains useful. Reconnaissance helicopters play a crucial role in modern warfare, providing real-time information about enemy movements and battlefield conditions. The Kiowa's lightweight design allows it to move quickly and quietly, making it ideal for scouting missions. Meanwhile, the U.S. military has been modernizing its fleet with newer helicopters like the U-872A Lakota. This light utility helicopter is replacing older models like the UH-1 Huey, bringing improved performance and updated technology. The Lakota is used for a variety of missions, including search and rescue, border patrol, and training operations. Its versatility and efficiency make it a valuable addition to the military's helicopter fleet. Over the past 2 decades, significant advancements have been made in helicopter technology. The UH-60M Black Hawk has received upgrades that include newer engines and digital avionics, making it more powerful, reliable, and easier to operate. These improvements have increased its speed and maneuverability, allowing it to perform better in high-stress combat situations. Similarly, the CH-47F Chinook has been modernized with better engines and avionics, improving its ability to carry heavy loads over greater distances. These upgrades ensure that the Chinook remains one of the most effective transport helicopters in the world. One of the most innovative additions to the U.S. military's helicopter fleet is the V-22 Osprey. This unique aircraft is a tiltrotor, meaning it combines the vertical takeoff and landing capabilities of a helicopter with the speed and range of an airplane. This hybrid design allows the Osprey to travel much faster and farther than traditional helicopters, making it an excellent choice for long-range missions. The Osprey has been used for a variety of operations, including special forces missions, troop transport, and humanitarian aid. Its ability to quickly deploy troops and supplies in difficult-to-reach areas has made it a valuable asset in modern warfare. Another major advancement is the AH-64D Longbow Apache, an upgraded version of the Apache attack helicopter. This model features an advanced radar system that enhances its ability to detect and engage enemy targets. The Longbow radar allows the Apache to track multiple threats at once, even when hidden behind obstacles like trees or buildings. This gives the U.S. military a significant edge in combat, allowing pilots to take out enemies before they even know they are being targeted. Helicopters like the UH-60 Black Hawk and AH-64 Apache have been essential in modern warfare, especially in conflicts like Iraq and Afghanistan. These powerful machines help transport troops, evacuate the wounded, and provide crucial air support during missions. Whether in combat or humanitarian operations, helicopters remain a key tool for the military. Helicopters play a major role in troop deployment, medical evacuation, reconnaissance, and close air support. They allow soldiers to be transported quickly, rescue the injured, gather intelligence, and attack enemy positions. However, warfare is constantly changing. Enemies are developing new tactics, and battlefields are becoming more complex. To stay ahead, the U.S. military must upgrade its helicopters to be faster, more efficient, and better suited for modern conflicts. As technology advances, the military is developing new helicopters under the Future Vertical Lift program, which will replace older models like the Black Hawk and Apache. These new aircraft will be faster, fly longer distances, and handle more demanding missions. One major project, the Joint Multi-Role Rotorcraft, is designed to create a new type of helicopter that can perform both attack and transport roles. It will be faster than current helicopters, with better maneuverability and more advanced weapons. The JMR rotorcraft will improve battlefield operations by responding to threats more quickly and covering greater distances. Another major development is the Joint Heavy Lift Rotorcraft, which will replace the CH-47 Chinook, the military's primary heavy lift helicopter. The JHL will be able to carry up to 29 tons of cargo over longer distances and at higher speeds. This will make it easier to move supplies, vehicles, and troops quickly, strengthening military logistics. The future of military helicopters will be shaped by groundbreaking technologies. Electric propulsion systems will reduce fuel use and increase efficiency. Autonomous flight capabilities will allow helicopters to operate with minimal human control. Advanced stealth technologies will make helicopters harder to detect by enemy radar. New designs like the Bell V-280 Valor and Sikorsky Defiant are leading this revolution. These helicopters will combine speed and agility, changing the way the military operates in future conflicts. With these advancements, the next generation of military helicopters will bring faster response times, more flexible mission capabilities, and lower operating costs. As war strategies continue to evolve, helicopters will remain a critical force in modern battlefields. The question now is, will these innovations be enough to maintain U.S. air dominance, or will rival nations take the lead? The technological rivalry between Russia and the U.S. has lasted for decades, with both nations leading in innovation and military advancements. This competition has produced groundbreaking technologies that continue to shape modern warfare. One area where this rivalry is particularly intense is helicopter development. But is Russia truly ahead of the US in this field? Let's explore the evolution of Russian helicopters and see how they compare. In recent years, Russia has been rapidly increasing its production of military helicopters, and the numbers speak for themselves. On August 7, 2024, Sergei Kamazov, the CEO of Rostec, Russia's state-owned defense conglomerate, announced that helicopter production had more than doubled under the state defense order. In 2022, Russia produced 296 helicopters, a massive jump from the 134 made in 2021. This sharp increase is part of Russia's effort to strengthen its military capabilities amid the ongoing war in Ukraine and rising tensions with NATO. Russian attack helicopters, particularly the Mi-28 and K-52, have become a major force on the battlefield. Since June 2022, these helicopters have been playing a crucial role in targeting Ukrainian armored vehicles. They have destroyed newly supplied Western hardware, such as M2 Bradley fighting vehicles and Leopard main battle tanks, while also supporting Russian assaults on Ukrainian positions. Videos released by Russian military sources often show these helicopters in action, demonstrating their effectiveness in real combat situations. Despite the decline of some Russian military equipment since the Cold War, Russian attack helicopters are still considered among the best in the world. The Mi-28 and K-52 were developed from scratch after the Cold War and have been produced in large numbers since the 2010s. Another key attack helicopter, the Mi-35, is a modernized version of the Soviet-era Mi-24 and remains in service alongside the newer models. These helicopters are designed to be heavily armed, well-armored, and highly maneuverable, making them a formidable threat on the battlefield. To increase their effectiveness, Russia has also introduced a powerful new weapon, the Vikhor-1 missile, specifically designed for the Ka-52. This missile allows helicopters to attack enemy targets from a safe distance, reducing the risk of being shot down by Ukrainian air defense systems. With Ukraine's air defenses weakening over time, Russian attack helicopters have become even more dominant in the war. On August 7, new footage was released showing a K-52 attack helicopter launching a guided missile to destroy a Ukrainian armored vehicle hidden among trees in the Zaporozhye region. These kinds of attacks have been happening more frequently as Ukraine struggles to defend against Russia's aerial firepower. The growing success of Russian attack helicopters has been largely attributed to Ukraine's dwindling stock of air defense missiles, making it easier for helicopters to operate freely over the battlefield. As Russia continues to ramp up its production of military helicopters, questions remain about how long Ukraine can withstand these relentless aerial attacks. With more advanced helicopters and weapons entering service, the battlefield is shifting in Russia's favor. How will Ukraine and its Western allies respond to this growing air power advantage? The most advanced heavy-lift helicopter ever built is about to be transported. Japan's brand new $500 million CH-53 is being loaded into the massive C-5 for air delivery by the United States. But moving such a huge machine is not easy. Crews must carefully remove parts, secure every section, and ensure nothing goes wrong. One mistake could cause serious damage. How does this giant helicopter fit inside the aircraft? What makes this mission so difficult? Join us as we explore how the U.S. is loading Japan's brand new $500 million CH-53 helicopters into massive C-5 for air delivery. The United States has built a helicopter that is stronger and more advanced than any heavy-lift helicopter before it. The CH-53 is one of the latest helicopters made for carrying large and heavy loads over long distances. It is designed to lift more weight, fly in worse conditions, and make work easier for the pilots. This helicopter is completely different from the older models, and it comes with new technology that makes it the best. For many years, helicopters have been used to move supplies, transport troops, and carry weapons into battle. But as time passed, the need for a stronger and smarter helicopter became clear. The older models had been in use for many years, but it was time for something different, and then the CH-53 was built. This helicopter can fly, travel farther, and take off in places where other helicopters would struggle. It can operate in hot deserts, cold mountains, and on ships in rough waters, but not for a long period of time. This helicopter was built to handle missions that no other heavy-lift helicopter could do before. The United States is not the only country that needs a helicopter like this. Japan has also decided to use this powerful machine. With the CH-53, Japan will be able to move troops and equipment quickly, respond to emergencies faster, and carry out military missions with better efficiency. This is important because the areas where Japan operates are full of islands and rough places, making helicopters the best way to transport heavy loads. The pilots who fly this helicopter have better systems to help them navigate, land, and take off in difficult conditions. The engines are stronger, the controls are better, and the entire helicopter is made to be as reliable as possible. In the past, helicopters had to be careful about how far they traveled with a full load. But this helicopter is designed to carry the weight of armored vehicles, large supplies, and important equipment. But the engineers noticed that this helicopter could do better, and it was decided to be upgraded. $500 million is said to be used to upgrade the old version of CH-53 helicopter. Every part of this helicopter has been upgraded, and it starts with what gives it power, which is the engine. The engines inside the helicopter are the strongest ever put into a heavy helicopter. They give it the ability to carry more weight than usual, fly higher than expected, and go farther without struggling a bit. The older version had to work harder to carry heavy loads. They used engines that needed more fuel and could not always handle the demands of modern missions. The brand new helicopter has new engines that produce more power while using fuel in a better way. This means that it can lift heavier loads without slowing down. It can also fly for a longer time before needing to refuel. But the engine is not only known for its power because it can do more than that. The engine can help the helicopter perform better in tough conditions. While the older version of this helicopter had issues with places like the deserts, mountains, and oceans, this one does not have this problem. The engines are designed to handle hot temperatures, thin air, and long-distance flights without losing power. Another big improvement is how this helicopter controls itself in the air. Pilots no longer have to fight to keep the helicopter steady. The brand new CH-53 comes with new fly-by-wire controls. This means that computers help the pilot control the helicopter. The system makes sure that the helicopter stays balanced, even in rough weather. It also helps the pilot make better movements, making flying easier and smoother. Fly-by-wire systems are used in modern fighter jets, but heavy helicopters like this have never had them before. The new CH-53 is the first to use this advanced technology. The older version needed pilots to make constant adjustments to keep the helicopter stable. This new system does that work automatically. The pilot can now focus on flying the mission instead of making small corrections every time. Inside the cockpit, everything is different compared to the old versions. The screens are bigger, the buttons are easier to use, and the information is clearer. In the older versions, the pilots had to read many different gauges and dials to know what was happening with the helicopter. But the new CH-53 gives them everything they need on digital screens. This makes it easier to understand fuel levels, altitude, speed, and other important details. The new cockpit also has better night vision and navigation systems. Older helicopters struggled to fly at night or in bad weather. Pilots had to rely on what they could see with their own eyes. This advanced helicopter has cameras, sensors, and radar that help pilots see in the dark through fog and in storms. No matter what the weather is like, this helicopter can complete its mission. Communication is another important area where this helicopter stands out. In the previous versions, talking to other aircraft or ground troops was not always easy. But this new version has improved radios and communication systems that allow it to stay in contact with multiple units at the same time. This is important in military operations where helicopters, ground forces, and command centers need to work together. This helicopter also has better self-defense systems. In battle, helicopters are often targeted by enemy missiles and weapons. This helicopter is designed to protect itself. It has systems that detect incoming threats and release flares or other countermeasures to avoid being hit. Other helicopters did not have strong defense systems, but this advanced helicopter was built to survive in dangerous areas. The materials used to build this helicopter are also better. It is made from stronger, lighter materials that allow it to carry more weight without being too heavy. Normally, helicopters have to choose between being tough and being light, but this upgraded helicopter does not have to make that choice. It is strong enough to handle rough landings and heavy loads, but light enough to fly efficiently. Another important upgrade is how this helicopter handles damage. In war zones, helicopters often take hits from enemy fire to the point that small damage could cause serious problems. The new CH-53 is built to keep flying even if some parts are damaged. It has backup systems that allow it to complete its mission and return safely. Maintenance is also easier with this helicopter. Other helicopters took a long time to replace because they had complicated systems that required a lot of work. The brand new helicopter is designed to be easier to fix. The parts are made in a way that allows them to be replaced quickly. The maintenance crew can get the helicopter ready for its next mission faster than ever before. The way this helicopter handles fuel is also improved. Older ones needed refueling more often, which made missions take longer. The new CH-53 can carry more fuel and use it better. It also has the ability to refuel in the air, meaning it can stay in flight for a long time without having to land. Everything about this helicopter is designed for modern missions. It is stronger, faster, and more advanced than any heavy-lift helicopter. It has better engines, better controls, better protection, and better technology inside. Every part of it is made to help the pilots do their job more easily and safely. The brand new CH-53 is a helicopter made for the future. It is made to handle the needs of modern missions, from military operations to rescue missions. This helicopter is a completely new way of thinking about how heavy-lift helicopters should work. It is the strongest, smartest, and most reliable helicopter ever made. And now it is ready to be used in ways that will change how missions are carried out across the world. This is the next generation of heavy-lift helicopters, and it is built to stay ahead for many years to come. Now, this brand new $500 million CH-53 is about to be loaded inside the massive C-5 for air delivery. But one important thing to note is that moving heavy equipment across the world is not easy to do. Ships take too long and smaller aircraft cannot carry enough. Some places have no roads, making ground transport impossible. The military needed a way to move the biggest and heaviest machines fast. That is where the C-5 comes in. It is the largest transport aircraft used by the United States military. It is built to carry tanks, helicopters, and supplies across long distances without stopping. This aircraft is a machine designed for heavy lifting. It has a massive cargo hold that can fit the largest military equipment. It can carry an entire helicopter, armored vehicles, and even multiple trucks at the same time. No other aircraft in the United States military can carry as much as this one. Loading this aircraft is different from loading other planes. It has a unique design that allows cargo to enter from both the front and the back. This makes loading and unloading faster. Other transport planes have only one cargo door, meaning everything must be moved in and out from the same side. The C-5 does not face this type of challenge. It allows crews to load from the front and unload from the back, saving time during missions. The size of this plane allows it to carry more supplies in a single trip. Instead of making multiple flights, it can complete the mission at once. This is important in military operations where time is critical. Troops need their equipment fast, and the C-5 delivers without delay. The engines on this plane are stronger than those on older versions of the aircraft. They allow it to take off with heavier loads and fly longer distances without stopping. Back then, transport planes had to land for refueling on long flights. This aircraft reduces the need for stops, making global transport easier. The aircraft is also built for rough conditions. It can take off and land on short runways, allowing it to reach remote bases. It can operate in extreme weather, flying through storms and harsh environments without trouble. One of the biggest challenges in military transport is moving helicopters. Helicopters are large, heavy, and difficult to transport by sea. The C-5 is one of the few aircraft that can carry helicopters. Most transport planes require helicopters to be taken apart before they can be loaded. This aircraft's cargo hold is big enough to fit helicopters without removing parts of it so that it could fit in. This makes it easier to move helicopters across long distances and have them ready to fly as soon as they arrive. This transport aircraft also has an advanced loading system. In other transport planes, crews had to rely on external equipment to move cargo inside, but this plane has built-in ramps and a winch system that allows it to pull heavy loads into the aircraft. This means that helicopters, tanks, and trucks can be loaded without the need for extra machines. The process is faster, more efficient, and reduces the number of people needed to complete the job. The crew inside this transport aircraft is small, but they are highly trained. The aircraft is operated by a few pilots and loadmasters who are responsible for ensuring everything is packed and secured correctly. Loadmasters must know how to balance the cargo to prevent weight issues during flight. Every item inside the aircraft is secured to prevent movement. If cargo is not locked in place, it can shift during flight and cause problems. Another feature that makes C-5 special is that it has the ability to refuel in the air. This means that it does not have to land to get more fuel. This allows it to stay in the air longer and transport supplies over greater distances without stopping. This feature is especially important during military missions where time is critical. The C-5 is also used for another mission. When there is war, roads are often destroyed and ships take too long to arrive. This transport plane can carry emergency supplies, food, medical equipment, and rescue vehicles to areas that need help fast. It has played a major role in natural disasters by delivering important things needed to people affected by hurricanes, earthquakes, and other natural disasters. The size and strength of this plane make it one of the most important aircraft in military transport. Without it, moving large equipment would take much longer. It allows the military to respond to emergencies faster, supply troops more efficiently, and deliver heavy equipment anywhere in the world. The C-5 should not be seen as an ordinary transport plane, but it should be seen as a machine built for speed, power, and efficiency. It is designed to handle the toughest missions, carrying the heaviest loads across the longest distances. Whether moving helicopters, tanks, or emergency supplies, the C-5 is built to get the job done. Meanwhile, moving a CH-53 is not simple. It is one of the biggest helicopters in the world. It is wide, tall, and built to carry heavy loads. Now that it needs to be transported across long distance to another country, it cannot always fly by itself. This is why the C-5 is needed. This massive aircraft is one of the only planes big enough to carry the CH-53. But fitting such a huge helicopter inside a transport aircraft is not easy. It takes careful planning, skilled crews, and precise movements to make it work. The first step in loading this huge helicopter into the massive transport aircraft is preparation. The helicopter is too tall to fit inside the cargo hold as it is. To make it small enough, some parts must be removed. The rotor blades, which are long and extend outward, are taken off. The tail section is also removed. These parts are carefully placed on transport racks so they can be reattached later. Even with these parts removed, the helicopter is still a massive piece of equipment. Once the helicopter is prepared, it is moved closer to the aircraft. This process must be done carefully. The plane sits low to the ground when loading, using a special system to lower its nose. This helps create a straight path for cargo to enter. A team of loadmasters, ground crew, and engineers work together to make sure everything is lined up correctly. If the helicopter is not perfectly positioned, it will not fit inside. The next step is moving the helicopter into the aircraft. This is not a simple task. The helicopter is pulled inside using a powerful winch system. This system slowly moves the helicopter forward, making sure that it does not hit the sides or the ceiling of the cargo hold. The clearance is small, and there is not much space between the helicopter and the walls of the aircraft. Every movement must be controlled with precision. As the helicopter moves inside, the loadmasters keep checking the position. They look at every angle, making sure it is aligned properly. If anything is even slightly off, they stop and make adjustments. They also watch for any parts of the helicopter that could get caught on the edges of the cargo bay. The process is slow, but it has to be done correctly. Once the CH-53 is fully inside, it must be secured. The helicopter cannot just sit freely in the cargo hold. If it moves during flight, there will be serious issues. Strong straps and chains are used to lock it in place. These are attached to special anchor points in the floor of the C-5. The loadmasters check every connection twice in order to make sure that the helicopter is completely secured. Though the C-5 is designed to carry heavy loads, but balance is really important. If the weight is not distributed correctly, the aircraft will not fly properly. The loadmasters calculate the weight of the helicopter and adjust the placement of other cargo if needed. Everything inside must be arranged in order to keep the aircraft stable during flight. Once the helicopter is secured, The crew prepares for the takeoff. The powerful engines of the aircraft are started, and it begins to walk down the runway. The pilots carefully lift off, making sure that the aircraft handles properly with the heavy load inside. During flight, the crew continues to monitor the cargo. They check the straps and make sure that nothing is shifted, and also confirm that everything remains secure. When the aircraft arrives at its destination, unloading the CH-53 is just as important as loading it. The process is done in reverse. The straps are removed, and the winch system carefully pulls the helicopter out of the cargo hold. Ground crews are ready to reattach the rotor blades and tail section so the helicopter can fly again. Transporting a CH-53 and a C-5 is not just about moving a helicopter. It is about precision, skill, and teamwork. The entire process must be done perfectly to make sure the helicopter arrives safely and is ready for action. Whether for military missions, disaster relief, or strategic deployments, the ability to transport such a large helicopter quickly is a major advantage. The C-5 and CH-53 together create a powerful combination. One is built for transport, and the other is built for heavy lifting. When they work together, they make sure that military forces can move fast, respond quickly, and complete their missions wherever they are needed. Thanks for watching. While you are still here, click on the link appearing on your screen to check out another of our videos. See you there.